On April 29th, a mile-long asteroid will make a close approach to Earth as it passes safely by. There's no need to worry, this asteroid will not even come close to hitting Earth. Our solar system is actually littered with asteroids and comets, and sometimes they do come very close to Earth. When an asteroid or comet could one day come close to our planet, it's known as a near-Earth object. But how close is close? A near-Earth object is defined as an object that could pass by our planet within 30 million miles. NASA begins to keep close watch on objects that could pass within 5 million miles of Earth. To put that in perspective, our moon is only 238,900 miles away. Now, this doesn't mean that objects don't pass closer to us than our moon. They do. But the moon is still very far away. However unlikely an impact is, NASA wants to know about all near-Earth objects so that we can track their movement through near-Earth space and predict their trajectories well into the future. The space agency has a Planetary Defense Coordination Office that maintains watch for asteroids and comets coming close to Earth in order to warn of any potential impacts. Along with its partners, they discover, catalog, and characterize these bodies. But what if one of these objects did pose a threat? If an asteroid were on a collision course with Earth, we want to be prepared. That's why NASA is working on several techniques and technologies to help deflect an asteroid on a collision course with Earth. Join us as NASA experts discuss April 29th's close approach and what NASA is doing every day to help protect our planet.
Hello, and welcome to a special virtual edition of NASA Science Live. I'm your host, Kelly Fast, and I manage a program here at NASA to help detect and protect our planet from near-Earth objects. As you might have heard in the news, an asteroid will be making a close approach to our planet this week. And while we can't be together due to social distancing, we have NASA scientists here to virtually answer your questions about this asteroid approach and help us understand how NASA keeps track of all near-Earth objects. First of all, this close approach really isn't so close since it will pass by millions of miles away from Earth. But before we can predict asteroid close approaches, we have to find them first. Let's watch this video that explains how we spot near-Earth objects.
How do we spot near-Earth asteroids? To start, survey telescopes scan the sky. When multiple pictures of the same spot show a speck that's moving, computers automatically check it against a database of known objects. If there's no match, it gets added to a list of objects to confirm. And if it looks like it'll pass very close to us, we give it top priority. Then it's time to call in reinforcements. More astronomers from NASA, other institutions, and even the amateur community submit additional observations. Each new data point helps refine the projected path, and this asteroid is going to fly right on by. All the info will be posted online, so it can continue to be tracked and monitored. Nice work, Planetary Defense Team. Keep watching the skies.
That was really helpful in understanding the various tools NASA and its partners use to discover, track, and monitor near-Earth objects, or NEOs, asteroids or comets whose orbits bring them into Earth's neighborhood. I'm joined by two very special guests, Lindley Johnson, NASA's Planetary Defense Officer, leading the Planetary Defense Coordination Office at NASA headquarters, and Paul Chodas, the director of NASA's Center for Near-Earth Object Studies at the Jet Propulsion Laboratory. So let's first talk about this large asteroid that is coming by Earth on April 29th, 1998 OR2. Paul, what is that all about?
Well, this is an asteroid that we've been tracking for over 20 years, and we've been predicting this close approach for a long time. It's one of the larger near-Earth asteroids, and so it's kind of notable. It's around 2 to 3 kilometers in diameter, maybe 1.5 to 2 miles across. So that makes it pretty significant, but it's passing pretty far away. It's passing about 4 million miles away from the Earth. So it's very distant, close approach. But it's notable because it's one of the larger ones.
Wow, and discovered 20 years ago. Well, Lindley, why is it so important to find near-Earth asteroids early?
Well, it's important that we find these asteroids as far out in time as we can, 20 years for this particular one, because the more time that we have to determine whether the asteroid is on a trajectory that could impact the Earth, the more time we will have to prepare for that and perhaps do something about it. Be able to launch missions to deflect the asteroid off of that impacting trajectory. We have to find them early as we can, so that we've got the time to select the right option and do the right mitigation measures to prevent the impact, if at all possible.
Well, so Paul, everyone is waiting to hear, how often do asteroid close approaches happen? Are they something to worry about?
No, they happen almost every day because there are just so many near-Earth asteroids, but the vast majority of them are really far away. So they're not that close in human terms. For astronomers, they may be, close. 1 million miles is pretty close for an astronomer. But, and there are a lot of small asteroids, really tiny asteroids, which can pass like inside the moon's orbit and come pretty close. But these ones are so tiny, even if they were headed for the Earth, which they're not, they would burn up in the atmosphere. So there's these two, categories. Most of them are really distant, close approaches. They're not that close at all. And then there's a whole bunch of really, really small ones that we're tracking that are really not hazardous to the Earth if they should happen to hit the Earth.
Well, Paul, often people see articles online claiming there's an asteroid headed for Earth, and at the very end, most usually admit there's no threat of an impact. But what can someone do if they hear about a close approach in the news and they want to find out for themselves?
Well, the first thing you should know is that we've been tracking most of these asteroids for a long time, especially the big ones. And so we really know their trajectories accurately. These stories you hear on the web, a lot of them seem to imply, there's some kind of threat or uncertainty that, the asteroid could hit the Earth. And that's just not true. We know the path really accurately. At CNEOS, we have a website. And so people can go to our website and get the table of all the close approaches, and you can sort them by date, let's say, and you can see which asteroids, you can see their names, you can see how close they're coming, how far they're coming, and how big the asteroids are. So we provide a close approach table, and it's open to the public. Everyone can take a look.
Okay, wow. So anyone at home can visit that website and look up close approaches for themselves. That's really cool. And so let's watch this video that your team made to learn more about it.
The Center for Near-Earth Object Studies, or CNEOS, at the Jet Propulsion Laboratory in Southern California is NASA's center for computing highly accurate orbital data for thousands of asteroids and comets that fly close to our planetary neighborhood. CNEOS collects this information from the Minor Planet Center, which includes orbital data and basic physical properties like size and rotation rate. If you'd like to find out more about these fascinating near-Earth objects, you can go to the CNEOS website and check them out for yourself. The first thing you'll notice on the CNEOS homepage are the top news stories. These articles describe some of the more recent and notable near-Earth objects, or NEOs, that have caught the eye of NASA astronomers. But one of the most useful pages is the one that lists all the upcoming close approaches. Understanding future near-Earth object close approaches is important because astronomers can then better plan on when to study them as they fly past. Click on Close Approaches and then NEOs in the navigation bar. Each line provides information about the close approach of an NEO, and by default they are sorted by time. The first column gives the name of the NEO, and the second gives the date and time of its closest approach. It's worth noting that 99.9% of the objects listed here are asteroids, and a very small number of them are comets. The next two columns tell us how close each near-Earth object will get to us. Note that the close approaches are measured in lunar distances, or the average distance between the Earth and the Moon, which is about 239,000 miles, or 384,000 kilometers. We also use AU, which is the astronomical unit, This is the average distance between the Earth and the Sun, which is about 93 million miles or 150 million kilometers. This first column is the nominal distance at which the object will come to Earth. This is the most likely closest distance as it zooms past our planet. The minimum distance column provides information on the closest the object can possibly come during its flyby, considering all possible uncertainties. This state-of-the-art CNEOS orbital modeling is very, very precise. We know the orbits of most of these objects with a very high degree of accuracy. The final column provides an estimate of the object's diameter based on how bright it is. These objects range in size from a few meters to a few tens of kilometers. But keep in mind that there are many, many more close approaches by smaller objects measuring only a few meters across when compared to the biggest NEOs measuring kilometers across. As this database contains a lot of information, you may also want to filter the table by time, nominal distance, and absolute magnitude, which relates to the object's size, by using the Table Settings options. Now you are familiar with how this page works, you can get more information about each of the objects listed on the left. So click on one of the NEOs to take you to the object's small body database listing. Here you will find a goldmine of orbital data. Click on any of the parameter names to find out what they mean. From here you can even display an animation of your favorite asteroid or comet orbiting the Sun. So if you hear about an interesting asteroid in the news, come to the CNEOS website and look it up. Now you can verify the object's flyby distance and lots more besides.
Well, thank you, Paul. That video is really helpful. So let's shift gears slightly and talk about NASA's Planetary Defense Coordination Office. Lindley, you are NASA's Planetary Defense Officer, and that's one cool job title. Can you tell us more about what you do?
Well, as NASA's Planetary Defense Officer and in charge of the Planetary Defense Coordination Office, I oversee the agency's program and all the projects that we have for detecting, tracking, and characterizing the near-Earth objects, but also in developing plans for what we would do if an asteroid was detected to be on a impacting trajectory with the Earth. So the word coordination in our name is very important because NASA will not do it all. NASA will work with other U.S. Government agencies like the Department of Defense, Department of Energy, and even the Department of Homeland Security to develop the government's response to a potential impact threat. But we also work internationally as well. We work with our colleagues in the European Space Agency, the Japanese Space Agency, and even Russia and the Chinese, in looking at what we would do as a world space-capable nations to respond to a potential impact threat.
Oh, that's really giving me a sense for what the coordination means in Planetary Defense Coordination Office. Well, we've got a lot of questions from Ask NASA, so let's get to some of them. So Martian Manish asks, how many near-Earth asteroids have been discovered so far?
Well, that's an easy one. It's about 23,000 near-Earth asteroids altogether, so that's a lot. The vast majority have been discovered by NASA-funded asteroid surveys, scanning the skies every night, looking for moving objects, and finding all kinds of asteroids and many near-Earth asteroids. I would point out that Congress has assigned the goal for NASA to find 90% of the asteroids that are 140 meters and larger. So there's an actual congressional goal and language that dictates that NASA needs to be searching for these. And the discoveries are going up pretty rapidly, about 2,000 or even more every year. So we're finding a lot.
And like we keep hearing them, find them, and so we've got some more questions here that are kind of related. Ravi Sangvi asks, which asteroid in the near future has a chance to hit Earth? Milady Shadow asks, let's say there's a huge asteroid hitting the Earth. Will NASA inform us? If yes, what will the world leaders do afterwards? And Patty Zenos asks, hey NASA, how far in the future can you predict an asteroid which will collide with the Earth? So Lindley, what do we do about it? You know, if we find something that might pose a threat, and will people be told, or are the data out there?
Well, first of all, we have to take enough observations, get enough observations to really be able to predict when in the future an asteroid might be an impact threat. And that's the job that Paul is in charge of out at the Center for NEO Studies. Then once the level of potential impact threat is determined, then we work with our colleagues in the U.S. government and international other space agencies to determine what might be the proper response. But Paul can answer about how far in advance we can predict these things, and what are the hazardous objects that are out there.
Well, we can predict centuries in advance if we have an accurate enough orbit and if we have observed an asteroid long enough. So it really depends on how long we've been observing an asteroid. But as I say, we can, that's the key thing. We'll have a long warning time. Now, asteroid Bennu, the one that the OSIRIS-REx spacecraft is at, is one of the more hazardous asteroids, but it's like for 200 years into the future. So we have a lot of time to study that asteroid and improve the orbit of Bennu. But the chance of even Bennu hitting the Earth are really, really small. 1 in 10,000 or so. Apophis is another asteroid that in the distant future, maybe within many decades, there's a small, tiny chance that it could hit the Earth. But again, as we continue to observe those asteroids, we'll probably be able to eliminate even these tiny little chances, 1 in 10,000, 1 in 60,000 chances of hitting the Earth. So, and as I say, they're in the distant future. There are no asteroids which have any significant chance of hitting the Earth that are of any significant size. There are none on our list.
And that's the whole point. None on the list, none that we actually know of, which is why we keep getting back to we've got to find them first. But you mentioned Apophis. Oh, go ahead, Lindley.
Well, let me just point out that impact of the Earth by an asteroid large enough to do damage at the surface is an extremely rare event. But it's an inevitable event. We know that there are thousands of near-Earth asteroids out there, or there are thousands more that we don't know about, and that's why we need to continue this program for detection and tracking of the near-Earth object population to determine where and when the next significant impact could occur.
And earlier Paul mentioned Apophis, and that is another asteroid that people ask about a lot. And Lyell 83513556 asks, "Hi, I wonder if there is a chance that asteroid Apophis could hit Earth by next flyby on 2035, depending on gravity or Yarkovsky effect, or did NASA and other researchers calculate that before they ruled out any possible effect, and is it safe on the 2060 flyby?" Can you tell us something more about Apophis and what people should expect?
I can address that one. Yeah. Apophis will come really, really close in the year 2029. So that's coming up, less than 9 years from now on April the 13th. And we know that it will miss the Earth. We know its orbit so well that we know its orbit within a few miles as it goes by the Earth then. It's harder to predict farther out. The year 2035, we're also sure that it will miss the Earth that year. And the year 2068, we're almost certain that it will miss in that year as well. But it will come close, and we don't know exactly how close. So projecting the asteroid orbit that far in advance, many decades, especially when it is passing repeatedly by the Earth, is a difficult problem. But we can see no chance of it hitting the Earth for many, many, many decades.
Well, and that's why it's important to observe it too. And I know that even now, observers around the world are already prepping for what they'll do at the time and for possible missions, and just brainstorming on that, because it does take time to launch such a campaign.
So Apophis is coming so close to the Earth, we'll be able to see it with the naked eye, in 9 years from now. That'll be an exciting event.
Exactly, yeah, that will be visible with the naked eye, which will be a really overwhelming experience. But that kind of brings us back to 1998 OR2 this week, because the Doctor _06 asks, will the asteroid be visible? And this one won't be, because whereas Apophis is going to come quite close to the Earth, 1998 OR2 is going to be about 16 times the distance from the Earth to the Moon away from us. That's quite far. So astronomers with telescopes will be studying it from the ground, but unfortunately you won't be able to go out in your backyard and see 1998 OR2 pass by. But there's another question here from Stacy Parsons 89 asking, does the name 1998 OR2 come from the fact it was detected in 1998?
Yes. The year is used as the first part of the designation. So it was discovered in 1998. And then we found earlier observations, so we actually know where it was earlier than that. And we've been tracking it for that long. That's more than, 20 years. We've been tracking this asteroid, and that's why we know its orbit so well.
Okay, well, maybe one more question here. Sanjeev Mechboy asks, suppose this asteroid is going to hit Earth. Have we technology in the present that we can destroy this in this way before striking the Earth? Lindley, do you have any comments on that?
Well, this asteroid is fairly large and indeed would be a challenge, but NASA and our colleagues in other space agencies, we are working on technologies and techniques to be used to deflect an asteroid that we discover on an impacting trajectory. The key to it is finding it several years in advance so that just a slight change that we would impart to its velocity will cause it to miss the Earth. But the technology that we're working on right now is our first demonstration of our capability to deflect an asteroid before it could impact the Earth.
Well, it keeps coming back to find them early, and so we don't end up needing the scenarios that show up in the movies and everything, where we can do it in a reasonable manner. And you all have some really great questions. Keep sending them in. Some of the questions we're getting are asking what NASA would do if there was a threat of an asteroid impact. And there is an exciting mission that NASA is developing to test an asteroid deflection technique in case we are ever faced with an asteroid that could impact Earth in the future. So let's take a look.
DART is the double asteroid redirection test. The Earth is hit by asteroids and pieces of asteroids all the time. Every year or so, we get hit by things maybe the size of a table. The kind of object that DART is going to visit is an object that's about the size of the Washington Monument. Those kinds of objects hit us every few thousand years, and they would cause severe damage on a regional scale.
We chose to do this demonstration at a binary asteroid. It's called Didymos. This is actually approximately the shape of the main asteroid. It's called Didymos A, and its moon, Didymos B. What DART will do is DART will hit the secondary. When it hits the moon, it will change the orbit period. And when it changes the orbit period, it affects the timing of when the moon moves in front of or behind the primary.
Mostly what we're looking to do is change the speed of the incoming object by maybe a centimeter per second or so. So that's not very fast, but if you do it enough seconds in advance, you can cause it to miss the Earth entirely.
So we just heard about DART, which seems like a really cool mission, almost like sci-fi. But Lindley, when is this all happening? DART's launch and the impact with Didymos B, when is that happening?
Okay, well, DART right now is in development. The spacecraft is being built up and being prepared for launch in July, the end of July of next year, 2021. It will then cruise to the asteroid for about a year and a half, not quite, 14 months or so. And the encounter with the Didymos asteroid and its moon will be the end of September of 2022.
Well, everything seems really well timed. Everything seems precisely timed. Why Didymos? We're hearing about how there's all these asteroids out there. Why Didymos?
Well, when we're encountering asteroids, everything does have to be precisely timed. We have to catch them at the appropriate time when they come close to the Earth. In this case, Didymos, nature has provided us this perfect opportunity almost to test the kinetic impactor technique for changing the orbit of an asteroid. Didymos is what we call a binary asteroid. The primary asteroid is about half a mile across, and it has a small moon, which is about the size of a football stadium, 160 meters or so in size. The DART impactor will impact the moon of Didymos and change the moon's orbit about the primary. This is a test, a demonstration of this capability, but we're doing it in a safe manner in that we'll only be changing the orbit of the moon and not the orbit of the asteroid around the sun, so we don't increase the hazard to the Earth from this particular asteroid by doing this test. So nature's provided us a very good test opportunity for the kinetic impactor. At the time of the encounter, Didymos will be about 8 million miles away from the Earth. And so this allows us to observe the effects of this impact from Earth observatories. Large telescoped optical observatories on the Earth can then determine how much we have changed the orbit of the moon about Didymos A. We also show that it will be close enough that it can also be detected by radar as well.
Well, it's nice that nature's giving us this opportunity to test such a mission, and hopefully we never need it. But Paul, how far in advance would we need to detect a threat in order for a deflection mission like DART to do its job successfully if we ever needed that?
Well, it takes time for a kinetic impactor mission to get to the asteroid, of course. It takes time to build the mission. It takes time for any change in velocity to take an effect and move a trajectory, away from the Earth. So we think that it takes you need a warning of at least 5 years to maybe probably 7, 8 years minimum if you want to execute a deflection of a sizable asteroid. So that is, I think, a minimum. We'd like to have a warning time that's decades in length. We'd like to, know decades ahead, and then you don't really need to hit the asteroid as hard. You can just, hit it a little bit, and over the time after the deflection, that will build up and make the asteroid trajectory miss the Earth. So the answer to your question is maybe 5 to 8 to perhaps 10 years is the kind of warning time you need in order to deflect an asteroid.
Oh, that's what we keep hearing, is find them early. Well, that's all for our show today. Paul, thank you for being here and to talk about asteroids and the Center for Near-Earth Object Studies.
Thanks for having me, Kelly.
Lindley, thank you for joining us to talk about NASA's Planetary Defense Coordination Office and ways we're protecting our planet.
You're welcome, Kelly. I'm very happy to do it.
And thank you so much for joining us to talk about this week's Asteroid Close Approach. The next time you hear that an asteroid is coming close to our planet, remember that NASA and its international partners are actively scanning the skies and studying ways to deflect any potentially hazardous objects that come our way. Thank you so much for watching.